Hey, how's it going, everyone? We are getting set up here. Let's see, click some buttons, make sure everything looks good. Oh, right, I'm gonna go over here. Getting set up. Let's see how we going over here. Maybe it's this one, maybe? Click on, I'll try this one, let's see here. See if this is the right one over here. Yes, okay, great, excellent. Zoom in, excellent. All right, so the plan for today, we're going to add a heat map for the output to visualize what the AI is answering. We need to see what the AI is doing over time. This is gonna be kind of an for me it feels like obvious what we're gonna see, what the outcome's gonna be visually. It will be neat just to try it out. Maybe there'll be a small little insight. We can also use it to help understand as we're optimizing and we're tuning the model using various different optimizers or loss functions, what it looks like different visually. And one of the future streams that I want to do that I think will be really neat is using every single loss function that Pytorch has to offer. That would be a fun, that's a neat, in fact, let's write that down really quick. Let's write that down really quick. We'll go here, 1, 2, 3, future stream idea. Use every loss function available in Pytorch. There we go, Pytorch, perfect. All right, that's the future stream idea. All right, so the plan for today, let's get going. We're gonna implement the heat map. We're gonna start with the heat map here. All right, so in order to do that, we need to track all the output that we've gotten over time, every single AI output in an array. So let's do that. Let's make that happen first. Okay, so where do we want to do that? So what is this for? AI list. Set AI prediction pixels, coordinates, output coordinates. Do we already have it? No. Okay. So this is the current number, and we need a historical number, so we can blit the output to the screen every single frame, and we'll do this in a way where hey man, Ahmad, how's it going? Good to see you. We're on the track to adding a heat map. So we're just sitting down. We're seeing what we want to design from a data retention perspective, and then how we're going to render it on the screen. This will be pretty neat. So right now we are storing the coordinates. We want to add in, hey Savon, how's it going? Hey Savon, good to see you. Happy Thursday. We're going to do the thing that you requested. The thing that you requested was implementing the heat map. So we're going to be, it'll be sort of a light map in a way. I don't know how heat oriented it'll be. We'll see how far we get. Good to see you as well. Yes, nice. Excellent. That's awesome. So I'm going to have like history. So this is like AI history output. So we need to do something like this to append. Like that. So that way get every single coordinate recorded. Then we need to add this in. Let's see this previous. Here we go. Let's do this. We will do underscore autocomplete. Oh wait, point list. We have so many lists in here. A few too many lists. History. Here we go. And this will be a list of lists. So good morning, Willie Sims. Good to see you. Happy Thursday. So we've got a list of lists. How do we do this? How do we do that? Here we go. A list of lists. Excellent. Like that. That's what we want. List of lists. I think we can do that. And inside, if we wanted to, we could also say that it's in coordinates or floats or something inside the list. We'll just keep it like this for now. I think that's fine. It's fine. All right. So now we've added that. Now we need to render it. We might get done with this really fast. We might be on a new record. I mean, this is like really easy stuff here. So we've got that. Now, this is, where's this being rendered at? Game, okay. Coordinates for the AI prediction. Where is this at? Okay. Draw circle. So this is, we need to do a for loop. Here. Is there a better draw? Maybe we can write a function. Let's write a function that does this for us. So let's see, def draw heat map. And then we need a game, I believe just the game object, and that's it. I believe that's it. That's all we need, just a game object. Then we'll just copy and paste this. Draw heat map, game. All right, looks good there. Been playing around with Llama. What's your feeling about it? Llama, like Llama, or Llama, the model from Meta Facebook? So that's probably what you're talking about, right? Meta Facebook. I'm pretty sure you're talking about the Meta Facebook Llama, like 3.2 or whatever this latest version is. I'm pretty sure. Hey, the Voss, how's it going, the Voss? Welcome on in. Good to see you. Happy Thursday. Happy Thursday. We're going to draw this heat map here. Let's indent properly. There we go. Llama. Nice. Llama. Llama's great. What's fantastic about Llama is it works on consumer hardware for accelerating large language models running locally on your system. There are other faster, more performant, server-oriented things like VLLM or something like that, which is very fast, and they implement flash detention and a bunch of extra performance gains. They require non-consumer hardware, specific H100, H200s, these very powerful $30,000 GPUs. So Python is so hard. Python's great. Python is great. Python is one of the easier languages, I'd say. Isn't the Christmas Day still? It is Christmas Day still, yeah. So it's okay to say Merry Christmas. It's still okay. It's still okay to say Merry Christmas. We're right at the end of the holiday, or I guess we're right. It feels like it's already over. However, for me, today is the day. Today is Christmas Day. So we got draw circle, and we're gonna do. We need to do a for loop for output in. We'll grab this game underscore history. Underscore history, please. Thank you. We'll draw a circle. And then we need to update this here. We need to update it. What language are you coding in? This is Python. Python. Hey, Mohammed, good to see you. Happy Thursday. Also, Merry Christmas. Still Merry Christmas. Happy holidays. Mateo, the Python programming language is my favorite programming language, mostly because it is a really nice way to represent most of the logic and all the math operations that you need for AI. That's what we're doing. We're writing AI right now. We're doing AI work. We're visualizing the output of the AI. It's fantastic. I really, really like it because it's simple, easy to read, clean. It doesn't have a lot of syntax that gets in your way. Fancy symbols, a whole bunch of crazy words, and it always has one major approach that it likes. I'm watching the day's musical performers. Nice performance, and there were some Carpathians, Christians, carolers on the national Romanian TV. I'm Romanian descent. Oh, really? Nice. I didn't know. And I'm trying to follow your coding, Stephen. Nice. All at the same time. So you get some nice musical, holiday musical in the background, and you've got some coding, Python coding and AI in the background as well. That's awesome. Hey, Carmu, Merry Christmas. Mr. Blum, did you have your plum cake, Mr. Blum? Yeah, we did all the holiday festivity things. We went over to Sam's house and family last night, and then they're going to come over here now. So exactly, nice, Savan, nice. That's awesome. That's great to hear. That's great. Let's get into it. All right, so so Savan here, if you don't know, is on, I believe, the horizontal feed. And recommended us to implement this feature right here, the hotspots or the heat map. We're currently implementing it right now. We're adding it into the code as we go. We're implementing it right now. You worked the graveyard shift, came home, and started Christmas dinner. Spiral ham, candy yams, stuffing and corn and peaches crisps for dessert. That was like a fantastic winter holiday festive dinner. That's a great one. That's great, Willie Smith. That's great. Getting back from the graveyard shift. That sounds awesome. What a really good meal. That's a great meal. That makes me feel like warm and fuzzy. I like that. It's really great. Okay, let's get into it. Let's get into warm and fuzzy. Talking about warm and fuzzy, we've got heat map. We're gonna heat up the screen and the GPU a smidge, because now we're gonna keep a lot of sprites on the screen. Although, from a hardware perspective, we should be perfectly fine, because we're only gonna have in the order of hundreds or thousands maybe of sprites, and this system can easily handle a lot more than that. Mohammed, Merry Christmas, wishing you peace and joy, lots of good moments today and always. Thank you. Thank you. Appreciate it. Appreciate it. You too. You too, you guys. Happy enjoyment of the adventure. All right, so this goes into output. We're gonna do this. Oh, you know what we should do is we should say chords like that. We say chords because it's a little more obvious. This is gonna be X and Y chords, right? Okay, so this will work. The only thing is I need to see what the background color is. And also, let's read some docs. All right, let's go over here. Pytorch. Oh, no. Pygame, which is our rendering engine. Circle, draw, and can we do opacity? Can we do that? Can we do semi-transparent? Maybe. Gonna highs, obvious or not. Python again. Let's go, right? Yeah, there you go. Yep, Python again. You got it. All right. Use separate transparent enabled surface and you blend onto your main display. Okay. Let's read through the docs here. All right. So here's our main circle surface. Okay. All right. We might be able to do this. Okay. So we draw onto our circle surface. We need a separate surface that we create here, circle surface. So that way we can get some transparency. That sounds good. Then we fill the screen and we blit the circle surface. Excellent. Okay. We could do that. So we can recreate the circle surface exactly. Let's see here. Do we need to import anything? No, we don't. We just run this. Okay. So we get circle surfaces. Okay. Let's grab this. Where do we want to put this? I suppose we could just put it in main. Right? Put it in main. We don't need to keep a state around or anything, I don't think. Although we probably need, it probably does need to be an in-game. So we could say Heatmap. Heatmap is a, what do you call it? Is a surface. Do we have anything? Yes, Pygame surface. Perfect. Heatmap. Excellent. There we go. Boom. All right, we got our Heatmap. All right, we're making it happen. Is this Gemini AI UI? Yeah, this is just Google search. Essentially, it's the Google result. So you Google search, and then it's Gemini. So it is like it's a nicer search. Let's put it this way: we could go onto the Pytorch website and look around and hunt for the answer, or we could just see. Read and then copy and paste. So either we're going to copy and paste from the docs, or we're going to copy and paste from a curated answer search. So there's a little bit of I do feel like it's cheating just a smidge, but it's okay. It's a little it's like right in between, I think. Shout out to Brownie1234. Brownie, hey Brownie, Merry Christmas. Oh yeah, it's Gemini. Yes, straight answer. Perfect. Yeah, it's a shortcut. It is a shortcut. We could be learning more if we were diving into the docs. Yep, absolutely. It would just take a little bit longer, and it would be fine. We could do it. We could do it. Merry Christmas. I'm working on a agentic system that can give an RCA. Ooh, a root cause analysis of system logs. Hey, there you go. That might be a tough one. Because the system logs are not always obvious, especially if you have a lot of system logs. And a lot of system logs. What do you think? Is it a good idea? It is. It's a great idea. The challenge is you need to have access to all the logs of every system. And usually an RCA is pinpointed to one little small problem in one of the subsystems somewhere. So getting an AI to find it, I don't know. If you can solve that, I guess the problem's logistics. You need to be able to access all the log systems. And maybe the problem isn't surfaced in the logs. So it won't always work. Humans still have to struggle and find, and then there's some sort of human intuition. So you need to also access the code base. So the human would need to say, here's the symptoms, here's what's happening, here's the code base, here's all the logs, and you'd have to dump all that data into an AI system, and it would need to be able to analyze that way. So it's a lot of logistical data putting into the system. So if you can solve that, you probably will do very well. You do very well. All right. So that we've got the screen here. All right. So Heatmap surface, good. We want to initialize the surface where we got this screen. Where is this at? We need to initialize it. Okay. Did we put it here? Circle surface. So this will be game.heatmap will be a surface. And I want it to be exactly the same dimension. So let's do screen equals this. All right. So we'll make screen equal to this. Equals that. And then we add that here. And it needs to be the same resolution. It needs to be exact same resolution. Screen. Here we go. Screen. Okay. All right. So we got the heat map. We got the game window screen. And then we blit onto, or we render onto the heat map, every circle. And then we blit the heat map onto the screen. And that should work. That should work here. And this is how we do it. And we'd say 0, 0, I believe. So game, we need to put this down lower. I'm gonna write this here because it's easy to see. Or we could do a split screen, reference that, go down to the section where we do need to draw it, and here we will draw it before the all right. So we draw the heat map here. Perfect. Okay. Redo screen blit. Well, we need to do this once here. After, so I do believe, okay, so draw a circle onto the heat map. Wait, game.window, hold on. One moment, where is this window? Okay. I guess we could say, this is being doubled up, isn't it? Wait, hold the phone, okay. So, we need to put this here, so otherwise that won't work. Okay. Then make this prettier so it's easier to read. Okay. All right. Heat map looks good. Screen. Here we go. All right, that looks good. Oh wait, the heat map's supposed to go here. 1 second. We need to do this. Heat map equals, like that, and then we need to here's what we got to do. This is what we got to do. This has to be 900 by 500, and this has to go up here. This will be screen 0, right? Screen 0, yeah. Screen 0. Oh hey Quantum, how's it going? Looking good with that shirt, Steven. Hey, thank you very much. Yeah, we're got some family coming over today, and I have to get all things ready. Get it all nice and fancy looking. So I figured I'd also present well. Got to present well, right? When you got people coming over to your house, it makes sense to present well. I still have pajama pants on. And I'm questioning whether I should put regular pants on, like regular other humans in the house pants, or just keep pajama pants on. That's my current question. While listening casually, opera mix. Yeah, I think so, right? What is it? Yep, there's a little bit of opera mix in there. A little bit of vocals. I tried to say contemporary music without was instrumental, non-vocals. It doesn't always get you. It doesn't always work. All right, so that should be fine. That's the screen dimensions. Hey, Block Fox just dropped by to say Merry Christmas. Thank you. Merry Christmas to you. Happy holidays and a good Thursday. All right, so I want to make sure that I didn't mess any of this up because I've been not fully coordinates for the AI prediction. That's just the initialization. That's fine. It's like the center of the screen. We could also do screen 0 and divide, but I don't need to bother with that. I'm testing my FFmpeg compression script on MP4 files. It works great so far. Nice. Very nice. Did you create your own container and encoder, or are you just testing FFmpeg directly and using it in your script? Happy New Year to everyone. Yeah, Happy New Year's on the way. It's going to be here in a few days. It's headed up. It's headed up here. Heat map, comma. We've got the comma there. You got a comma there. Let's see here. Screen display mode looks good. Screen.fill. I don't know why we have this all looking like that. We can keep Make it look green. Screen it fills here. Okay, so this is the background color. All right, so that's the background color. Which we don't need anymore because now we're going to be using transparency, or we're going to set an opacity level. So that's the plan. We're going to set opacity. Not using others, not mine. Oh, got it. Okay, got it. Makes sense. Understood. Sounds good to me. All right. All hail open source. Isn't it great? Isn't it great? Open source is fantastic. It's the way of the internet. Makes things accessible to everyone. Make it all accessible. All right, where do we leave off? All right, so we got our heat map. We've created the surface, which it has alpha. It's got alpha in it. Now we need to blit or draw onto this surface. That's what we have to do. We have to draw onto the surface. Where is it? Heat map. Okay. Let's see. Our heat map draw is functions here. Game.draw.circle. Game.heat map. I think. I'm pretty sure. Heat map. Okay. Then we've got the coordinates, the size of the circle, and then we also need to add the opacity somehow. That should be in the docs here. How do we do this? Let's see here. Oh, I see a fourth one. Okay, here it is. So here's number 4. This is the translucency level, 0 to 255. Excellent. So I will put on a. We'll do 120. Keep everything nice and smooth. All nice and smooth. Okay, so that should give us some translucency there. Essentially in the middle of translucency. Let's bring this up to 255. So it's a little bit hotter. 255 here as well. And then 128. Excellent. And then, yeah, sounds good to me. All right, so this will be the color. So we'll draw that onto the game surface, which supports, and this should be 0, 0. Okay, 0, 0. 0, 0. Looks good. Okay, so we blit the circle surface onto the screen surface. Game.screen, I believe. Let me see here. Game.window.screen. Where do we blit that at? Let me see here. Flip display, marker, circle, window.screen. Okay, so it's this right here. That's what it is. Okay. Let's see. So like this. Probably. Somehow, maybe. What is window? Let me double check. Window. Maybe. I don't know. Let's double check. Game display flip screen.blit. So our screen is going to be defined somewhere around here. Where's our screen? Okay, here it is. It is the display. Okay, so that is the display. And then it is the game display set mode. So here, game display set mode. Where's that at? I want to see that. Game display mode. So it is the screen. So it is game window screen. Perfect. Okay. So that should be, it should be this. Yeah. Excellent. All right. Looking good to me. So this should, we haven't even run the program yet, and we've been writing code for about 24 minutes now. About 24 minutes. Can we get it to work? Will it work? I don't know. We've never done this before. Did I miss anything? That's what I'm wondering. I'm wondering if I missed anything. All right, so here. So it's not, this is a problem right here. Obviously, that's not going to work. It's called game.heatmap. That's what we need. So yes, we did miss something. There we go. Game heat draw heat map. We rendered this. Yes, that's there. Let's close that. Game looking good. So put it above, or sorry, below. We need it below everything because it's sort of the background, right? So I think that's it. I think that might be it. Maybe. Let's see here. Let's try it out. Let's see if we get any errors. An immediate error. Failed. Okay. Non-default argument draw follows default argument heat map. I do not understand. Data class. Where is this? It says data classes. Nope, that's not a problem because obviously we don't have anything to do with that. Oh, maybe it's how we're defining it. All right. Let's see here. Game definition, please. Here we go. Game up here. So it's probably this. Right here. Yep, that's it. There we go. Figure it out. You got a 15 gigabyte 7 zip. Did nothing at all. Maybe a few bytes. I'm testing FFmpeg. Shows great results. Hey, there you go. Some compression. Get some. I'll see final results. How much I got from the 15 gigabytes. Sounds good. Let us know. That's a lot to compress. That's a lot of compute. All right, so that should make it less annoying. All right, so we fixed that bug. We fixed that one. All right, now we're on to the next problem. Game init missing one required positional argument AI history. Yes, all right. I remember that. We just need to initialize it to an empty list. So game. Here we go. Right here. AI history equals empty list. All right. There we go. We're onto it. Hey, we did it. Look at that. Now you're seeing all the. It's not perfect yet. It's not totally perfect, but it's better. You can see it's not like a heat map. It's just more of a hey, where has it been over time? This is actually pretty great. You can see what the visualization is as it's training. So it's kind of close to what I thought it was going to be. It's not exactly what I thought it was going to be, but we did it. So now, as you can see, it's centralizing, which is still a problem. I think it's still a problem because it really needs to track independently. So what I'm thinking is another thing that we need to do is add in a different model. We need to add in some LSTM layers. So as you can see, it stopped. It stopped, which is wrong. We also want to increase. All right, so I've got two ideas. LSTM increase. Okay, to do increase. Here we go. Increase number of input XY chords, and then we also want to do potentially an LSTM, maybe LSTM. I know it's old now. There's transformers, so we don't have to worry about. Most people don't bother with LSTMs anymore. So I'm thinking that we could probably add, an LSTM input, a sort of an input layer there. Also, we could reduce params. I want to do this one right now. And then we also need to improve this. Make prettier. We see if we can make that prettier. We could probably get maybe if we could do. I don't know if Pytorch supports a gradient circle, a radial gradient. I want a radial gradient. Steven, do you have a theme friend? I know what you're talking about. Not currently. So just here with you right now. So I don't know. We're just here. Here we go. So yeah. Prettier LCM reduce parameters. All right, so let's reduce the parameters real quick. I think we can do that. Where is that? Where's our model at? It is where I thought I would see it really. Here it is. Excellent. Okay. Let's go down to, let's do 8. Let's do just 8. 8. All right, so now it's really small. I think this will cause the model to jump around a lot. Hey, Rashab, hey, how's it going, Rashab? Good to see you. Happy Thursday, Merry Christmas. All the things. We're visualizing data. Now, here we go. There we go. All right, so yeah, is it jumping around more? Is it centering more? It's less chaotic. It's less chaotic now. It seems to like immediately be centering on the click. So it's not actually predicting what I want. And it's kind of drawing a dragonfly. What is drawing? It's really weird. That is very odd. I was not expecting that. Now I don't know what it looks like. That's pretty neat. It's confused, isn't it? Meso is confused. It is a little bit. So what we need, as you can see, it's kind of learning, but not in the way that I want it to. Not quite in the way I want it to. I want it to be able to track let's predict the actual output, right? So I'm clicking all over. However, it keeps centering. Like it keeps averaging things, and I don't want it. Code takes a lot of time, bro. It does. You got it. It sure does. Okay, let's close that. Okay. So we need to, here, let's increase the number of coordinates. Let's go 8. And then we also need to update. So there's number of XY coordinates, number of features. So yes, there are 8 input features, right? 8 input features, which means that our model, which is around here somewhere, model, here, needs to be 6 and then 2 output, right? So there's actually, so 8, -8, -2 offset means 6 features or 3 X's and 3 Y coordinate. So that will be a total of 6 input features. Let's see what that does. Let's see how that changes it. All right, here we go. Here we go. Is that going to make it better or different or the same? It looks like it has made it center a little bit better. It's like making a weird little, is it going to make it, what is it? A shrugging symbol? I don't know what it is. I'm not exactly sure. We should make the heat map a little prettier though. Although it is very nice to see all of the outputs. Visualize it this way. And you can also see where the current is. So I like that. I like that. All right. It's very interesting. Why is it doing that? Can anyone suggest a good open source vision model, not GPT or Gemini? Oh, vision? Yes. Okay, so Ultralytics. I think Ultralytics, right? So YOLO. Let's check this out. YOLO Ultralytics. Here, this one. It's a good computer vision model, open source. Where is it? There's got here. Object detection, right? Object detection. That's what we're looking for. Here we go. So you can zoom in. Wait, open image in new tab, please. Yes. Oh, what? All right. We'll just zoom in on here. Okay. So you see how it detects a person and it detects other objects in the scene. Obviously, it's not detecting like a sign or a button, though it probably will. It'll probably detect those as well. This is just like a demonstration image. So yes, Rashab, the answer is YOLO Ultralytics. YOLO Ultralytics. Isn't that neat? I think it's neat. I think it's pretty great. And it looks like they're on version 11 already. Wow. The last time I looked on it, they were version 8. That's fast. That's amazing. So yeah, so YOLO Ultralytics. It's called YOLO Ultralytics. I'll put in detection, object detection. Oh, it's a vision model, right? So I'll put this over here in our Discord under the free resources section. Free open source. All right. Okay. Let's get back over to this. All right, we got 30 minutes. We got plenty of time to mess around with our adventure here. Let's turn that decay off. Let's see if that works any different. Okay. Let's try this again. All right, where are we at? Here's the outputs. Whoa, whoa, that's it, jumping around now. Look at that. Okay, so is it doing a little bit? I would say it's doing a little bit better. This is a little bit closer to what I want. See how it knows it's popping? Okay, so now it's not doing what I want. I need it to get close. It's very interesting to see how it's learning over time. This lets us know that it's not the right model. We need to improve the model. So we can do that. We can absolutely do that. So let me add that in the to-do here. Okay, I'm going to close that real quick. Okay, to-do. I guess improve model. We'll just say improve model. Sounds good. All right. Improve model for, I mean, we have that here. It's like right here, right? So obviously, to reduce parameters, which we did. We can increase parameters, increase number of XY coordinates. So yeah, so here is just the overall improve the model. Steven, what local LLM do you recommend for coding on a low resource, no GPU, only CPU? That one's tough because CPU only is going to be very, very slow. Like very, very slow. Like 1 token per second, which means you could type like 90 token. You could type a lot faster. Like humans can type words per minute, a lot faster than that. Can you try this one? I don't know if this works. It is Olama Jim. Let's go to Olama. Then go to models, and then look for Gemini. Is that here? So this I saw. Oh, is it cloud only? Okay, so tools. Okay, so it's cloud only. So this is not local. DeepSeek R2, but it's too big. There's Code Gemma. Powerful lightweight models can coding tasks. Okay, so this one might be pretty good. So this one is probably going to give you a pretty good, and so it's 5 gigabytes, or 1.6 gigabytes. So this will work. It'll perform pretty well. So Code Gemma, right? I think Code Gemma is pretty. For example, to run on a Raspberry Pi, maybe diffusion LLMs. Yeah, those would also be good. I would recommend trying this one to see how well it does. Because it's very small. It's very small. You just mentioned like a file of 15 gigabytes. Like the big model here is only 5 gigabytes. So you use Gemma and Quinn. Oh, so you're already on it. You're already on top of it. Nice. Very nice. Yeah, Quinn would be good. I would say DeepSeek R2. And then, yeah, I say Quinn. Let's see here. Interesting. Yep. There you go. That's it seems like you're already on top of it. Because I use mostly like Claude and OPEX, Codex, and Gemini myself. Can you explain what you're doing? Yes, Meso, I will. Absolutely. Let's explain what we're doing. Trying to achieve, having to try to understand, is it tracking points, X, Y? Yep, you're right. Via X, Y coordinates, you got it. And the output is supposed to see the pattern. So it sees where the last few clicks are on the screen, the last few X, Y coordinates. So it looks at the previous 3 XY coordinates. Currently, we might change that. It will then predict where the next click will be. We need to improve the model in a way to where it actually is starting to do that. Because I am clicking in a general pattern, mostly in a circle pattern. And so the AI should be able to learn those patterns. We might need to increase the number of features that we're using. We might need to change to an LSTM. These are the improvements that we need to make to the model, so that way it actually starts really predicting where the clicks are. Oh, hello. Amish, hello, how's it going? Happy Thursday, Merry Christmas. You can use anything with a 2 billion parameter, or use multiple depending on task. Oh, it's a good idea, Rashad. Yeah, exactly. 2 billion is a very good number. It's easy. CPU level, you'll probably get decent performance. It'll be still not be super fast, but it'll still be workable. Karen, is AI going to take over the world? It kind of already has in a way, right? A little bit. It's already taken over. Everyone now uses it. Everyone's using it. And these are just generative AI models, right? And they're mostly driven by human ambition. This is your tasks and activities that you're driving its output. And that's how it's being shaped. There's no intelligence behind it. It's kind of like an oracle. It's only going to do what you ask it to. Pretty neat, I think. Pretty neat. Whoa, hey, 667 for 67 joules. Karen, thank you. Thank you for sending over the joules. That's a good 67 joules. What are you doing over there? Karen, thank you. Karen Spilsbury. Karen Spilsbury, thank you. Thank you for the joules. Merry Christmas. That's a great holiday gift. I appreciate it. Thank you. It's a good motivation. That's a good motivation here to get our heat map. Maybe we can improve our heat map. Can we make the heat map a little prettier? I suppose we could. We could make it a smidge prettier. How do we want to do that? I suppose we could. Can we do a radial gradient? I think that would make it better. If we could do a radial gradient rendered onto the screen, that would be a lot nicer. Let's try that. Let's do that. Pygame draw radial gradient. Let's see if we can do that. Is it possible? It looks like it is, and it just requires extra code. Surface, center point, radius, start color, end color. Okay. How is it doing this? Okay. Okay. Then it renders, it walks through So we would have to draw this ourselves. There's no built-in native function. And I don't necessarily want to copy and paste this. Screen, red, blue, red to blue. We would convert this into also so I want it to be the main color and then taper out to a transparent color. So color step. So is it drawing? It's just drawing a whole bunch of circles. We could do that. We could absolutely do that. That's really easy. And it would look heat map like. Okay, I like that idea. I think that's pretty neat. We could do that. We don't need the code anymore. We can do it. We can do it from memory. Draw heat map. All right, so we can do that. All right, let's do that. I think this will be fun. This might be the last thing because we only have we got 20 minutes left. Hashtag exclamation today. Fractal Cow. Hey, how's it going, Fractal Cow? Good to see you. Merry Christmas. Steven, want to know something you didn't know, but you should have known? Yeah. Tell us what is that? SAQ 3000. What do you got? Okay. Excellent. Oh, Fractal Cow. Oh, you're over there on Twitch. What are you doing? You're on over there on Twitch. Fractal Cow. Good to see ya. Okay, so what we need to do is we need to have. If this is actually really easy. I can't believe. Look at this giant code blob. You see this giant code blob? And what we're going to do is we're going to make this different. We're going to make this different. Bro, enjoy Christmas. What are you doing here? I know, Kareem, well, that's the plan. It's early morning for me. I always wake up early. My alarm goes off at 4:30. I sleep in a smidge. I click the snooze button a few times. Then I wake up, get ready for the day, make breakfast and food for the rest of the day. And then I'm ready to go. And now I've got some time to stream. And then I've got a whole bunch of house chores because the house chores can be completed before family visits. So family's going to be here. They'll be here. So that's why I can't stream very long today, but I wanted to be here anyway because I stream every weekday and I didn't want to miss today. So we got plenty of time. All right, this is great. We can make this happen. This is really neat. Okay, so we'll do 4i in range. We'll do 10 circles. We'll do 10. All right, we'll do 10. So I times 2. And then we will do this. How do we want to do this? Negative I times 2, maybe. No, times 20. No, that's too much. Do times 5, maybe? Okay, we'll try that. Let's see if that works. Is that going to do? I don't know. Or are we doing it in the right direction? That's what I want to know. Are we doing it in the right direction? Is it going to be the opposite of a radial? Or is it going to be like... What is it going to look like? Hey, Aiden Harris, Merry Christmas. Happy to have you here. Kareem, send me the Christmas gift into your account. What Christmas gift are you hoping for? Did you have a good Christmas? Did you open your gifts already? Did you have a good Christmas? I hope you did. All right, so this should be pretty neat. I think it'll be pretty neat. All right, let's try this. All right, are you ready? I'm actually kind of curious if I only need to draw this one time, and then because I'm not, it's a surface. I might be overdrawing. So here, I need to do here. Amish, hey, Merry Christmas! Thank you for your Merry Christmas. Happy to have you here. All right, so to do optimize. Do we need to re-render every circle always? Or it's the surface. I think the surface is rendered once and we should be good. So we don't need to re-render over it. So we might not need this history. We might not need this. I think we don't need the history anymore. So I think we can do that. Bro, you are live. That's your gift. All right. Nice. Thank you. Thank you for saying it. That's very nice that you did say. That's a really good compliment. We like that. Is there a way to create an NCP based connection SSMS? What? What are you talking about? Create a model context protocol based connection to SSMS. What is SSMS? I don't know what that is. Are you talking about short message? Steven, I showed my question. Read, please. Oh, sorry, I missed it. I missed your question. Thank you for reminding me. Search PMH, perpetual motion holder. Okay, based on how it works, I think it is a magnetic capacitor, which a lot of people are not talking about. So hard drives working on this concept. It's crazy silenced. Okay. Merry Christmas, Amish. All right. So what? Let me think about that for a second. Let's see here. Will you explain the machine learning roadmap from one specific website? What? Which one? Hey, KK, thank you for subscribing, KK. Welcome on in. SQL Server. Oh, Server MS. Yeah, you absolutely could. There's no reason why not to. In fact, it should be pretty straightforward. It should actually be a really easy MCP to create, like a very easy one. Very, very easy. Bloodfire, do you have GF? Do not currently. Thank you for asking, though. Thank you for asking. Okay, so SAQ 3000. Let me see here. Perpetual motion holder. Let's look that up really quick. We are running into some time here. Perpetual motion holder. What are we? Let's look at some images here. Like this sort of thing. What is this? Oh, where it constantly there's like a magnet here, and so it keeps things going basically forever. Magnetic, yeah. I wonder if there's like an image. Is there like a video of this or something? Basically, it's just going to swing back and forth forever. You haven't answered my question. Oh, Kareem. Yes. Okay. Will you explain for me machine learning roadmap from one specific website? Which website you're talking about? Are you thinking just any website in general? Any website? No, it's simple metal plus wire. Oh, got it. So something more like this, or let's see here. I see here. So something like this, metal and wire. And it's a capacitor, right? You said capacitor? Yes, in general. Okay, Kareem. Well, that's kind of what we're doing on this channel. It's going to take many months, though. It's not going to be a quick run through. We are currently using Pytorch, and we're going through all of Pytorch. The goal, probably, it's going to take months. We're going to go through every single Pytorch item. We're going to do another stream, I believe Monday, maybe, depending on time. We will go through all of the Pytorch loss functions. That's what we're going to do on Monday. We'll see. We'll try every single loss function. We'll see what it looks like. That's why we're kind of building this visualizer right now. So yes, Kareem, we'll do it. It's just going to take a while. What would you recommend learning after machine learning? Like, I want to proceed with Gen AI. Generative AI is a good follow-up, right? So transformers, encoding, decoding on the tokens, and then you should be good to go. I think that's it. Do you have any advice for people who are in university just very early in their career? Bloodfire, definitely focus on the common languages of the industry, which are going to be Python and JavaScript. SQL, they might have, if you go, those sorts of things. I want to actually create pipeline through which I can, let me see here. Too many chat messages. Bro, PyTorch's deep learning framework. It is. Yes. Are you talking about so if you're talking about non-framework, we've already did a live stream for this. Just look for AI from scratch or machine learning from scratch. We did this. It took, I think, was it like 7 streams or something like that? Around 7 different streams. So probably a few hours per stream. So that one's also good, Kareem. You can go look that up here. So that would also be available. Just read the whole message, please. I might not, let's see here. Now the products are a different domain, even if they are the same domain, but different brand. So no pattern in prices. That is why you're thinking of using images to create some more features from it. Like packaging types, design aesthetics, material quality, premium scores. So far that you need an open source vision model. Oh. Well, Rashab, I don't know if you would want, for that sort of thing, you need to create your own, right? I don't know. Ultralytics might work for that. So you could classify. So here, you might be able to do image classification. So that would also work with Ultralytics. That might work better. Or you need to create your own. to a vision transformer or a convolutional neural network. That would be my recommendation. Did you see the new Function Gemma today? Agent by the Google. I did not. Let's check it out. Function Gemma agent. What do you got here? Let's type that better. Function Gemma agent. Does it even... Okay, Function Gemma. It's right here. I see it. Hold on 1 second. New function. Not worth downloading. Google Function Gemma. Build your own function callings. Excellent. Nice. LLMs. Okay. Oh, nope. All right. See if we can get rid of that. All right. Good. Everyone keeps shipping bigger models, more parameters, more VRAM, more access for the server needs. Function Gemma goes in the opposite direction, and that's what makes it interesting. Function Gemma is a lightweight open model from Google built specifically for function calling, not chat, not reply, not helpful assistant, just a structured intent to function translation. So this is actually one of the things that I would like to use a majority of my time. Usually when I'm using an LLM, I'm going to be using function calling. So Function Gemma is a purpose built specifically for that. That's really powerful. That's really, really powerful. I like this. Thank you, Fractal Cow. Thank you for mentioning this. I really like this a lot. This would be like the best way, I think, into creating an AI agent that performs specific tasks for you. Function calling, tool invocation, agent workflows. That's exactly what I want. On-device or offline automation. And it can work everywhere. Only 270 million parameters. Really? That's pretty great. This is a deliberate but lowers the barrier to deploying agentic systems without shipping user data to a server. All right. Thank you, Fractal Cow. This is great. I love this. This is actually really great knowledge. Function Gemma. There we go. Function Gemma. That's great. Thank you again. Okay, so let us go back to this. All right. So let's see if we can make that pretty. What is that going to look like? Nothing at all. Did that not do what I wanted it to? Maybe. Let me see here. Okay. Why that not work? Okay. Let's do 10. Okay, let's do 10. And then, so this is going to be 20. And then I suppose, how are we going to do this? 255 maybe? Let's do 255 and we'll do this 25. Right? See if that's better. Is that going to do anything better? No. Interesting. All right, how do we get this to work? Where is it? I want heat map. Here we go. Surface, alpha surface. Yep. Okay. Oops. Your files were 1.5 gigabyte. I got reduced by 400 megabytes. Oh, got it. That's awesome. Yo, it worked. 400 megabytes is a huge gain. That's a lot of compression. That's a huge compression. Nice, SAQ 3000. You did it. That's great compression. That's a fantastic compression ratio. All right, so let's just set this to 10. Let's see if that, there we go. And then we won't do this. I would say 20. We need to debug this here. Okay, so that is working. That part's working fine. Okay. Then why is this not? Oh, here. Let's do something else. Instead of this, let's do this, and instead of that, I want to do chords equals this. I think we don't need to loop over a history. Let's see if that works. Okay. Was I right? I was right. Okay, good. Okay, great. Excellent. Okay, so we optimized that. All right, and so we don't need AI history anymore. We'll keep it for now. To do remove AI underscore history. It didn't even compress, like it output to the 7-zip output was actually the same as input. So you gave it an MP4 file And oh, GSEV, compressed, same format, MP4, everything same but small. Really? So essentially you're using MP4 compression. Is that what that is? You're using but MP4 is a lossy, right? It's a lossy. Well, MP4 is just the container, right? And the encoder can live inside the container MP4 format with the headers and data frames. The yellow faint trail is the heat map. Yes, Savan, yes, exactly. And we're trying to make it prettier. We're trying to make it good. So let's see here. Let's see if we can draw it better. So I want this to be let's do two. Let's do 2 100. Okay. So I'm going to try to make like a radial gradient so it looks more heat map like. Yes, there we go. Okay, so that's exactly what I want. Thank you for the likes, you guys. Thank you for the likes. The code below. Wait a second. Okay. So we see. It's kind of neat to see it like a little dot like that. Now, let's see. Let's pause this up. So it's a neat way to see this. All right, so let's go 255. I want to make sure that looks exactly like how I want. Okay. Yeah. Yes. Excellent. Okay. So we should be able to do a radial gradient. I times I. Right. So that should make it big. Yep. That should make it big. Great. Input VS code lib 264. So H264 and a CRF, which is 28 in the output. Okay. Okay, got it. Yeah. Yep, that makes sense. You don't know it works? It sure does. That would absolutely work. Okay, so your input, you're starting with a video, and then you're compressing it further. So you're decoding it using FFmpeg, re-encoding it using X265 and with a CRF 28. So that should absolutely reduce the file size. Okay, that absolutely makes sense. Yes. And it should be, it won't be human noticeable lossy. It's still a lossy, though the visuals will still look to you and me as a human unchanged. So it should look very similar. That should make a lot of sense. All right, so I want this to be times I. See if we can do that. See if that looks better. We almost got it. It's just not quite there. Does it? This is very odd. It's very odd. Let's reduce that down. This should be. We might need to go in the opposite direction. We might need to render in the opposite direction. Let's see here. I minus 10. Something like that. How do we go in the opposite direction? That's what I'm thinking of. Range. Can we go range 10 to 1? Actually, let's find out if we can do that. Let's see if we could. Yeah, 10 to 1. Then we could just say I. See if that works. 10 by 10, so that would be 100. Hey man, hey, how's it going? Is it work? That's weird. There's nothing showing up now. Oh, we'll figure it out. Abhishek, hey, how's it going? Good to see ya. Merry Christmas, Happy Holidays. All right, how much time do we have? We're out of time. All right, I really want to get this heat map working the way I want it to work. Let's see if we can get it to work. All right, so 1 second. Python a equals range 10, 1. Can we do that? A for I in A, print I. Okay, so it doesn't do what I wanted. Okay. So we have to do it like this. 4 minutes? I know, right? Only 4 minutes. Wait, we do have to get going. So So we do have to go. Savant and SIQ3000, everyone, thank you for hanging out. We do have to go, though. Before I go, I really want to make this work, and then I have to go do house chores to get ready for everyone to come over for holiday festivities. Shouldn't we make it scattered, enlarging the turning red from green circles where the rate of clicks? Yes, exactly. So before I get to the changing of colors, which is right here, I want it to a radial gradient. I want to draw a radial gradient. So I have to draw the outer circle, the big circle first, which is lightweight, because it seems like when it's blitting onto the surface, it's replacing whatever it blits over. So I'm drawing inside to outside right now, which is going to overwrite the circle gradient, the radial gradient. I need to draw from the outside in. So we have to start big to small is what we have to do. We have to go big to small. So how do I do that? Negative I, we'll say 20. 20. And we subtract. Here, I've got an idea. We subtract I times 2. Like that. Okay. So we go the opposite direction. So that right there, that one thing should make it visible. Let's see here. Python main. Okay, let's see. Does that make it visible? Yeah, there we go. If only. Okay. So it is kind of working. As you can see, though, it's taking the background color, and it is a radial gradient, but it's not actually alpha. Hey, Kyle, Merry Christmas! Merry Christmas! Good to have you here. You got here right at the very end. So we did it. We got the radial gradient. It looks good. It's efficient. It's taking the surface background color, and it's not actually a truly transparent color. Looks like Christmas lights. I know, right, Kyle? Doesn't it? It looks like Christmas lights. So we did get the radial gradient going. It's just that it's not. It's a very weird. It's a very weird surface. So, it's very odd. Oh, hey, Emmanuel, Gimelick. Hey, thank you for subscribing. Welcome on in. So you've subscribed just at the right time because we're right about to head out. We are going here in a bit. I'm wondering if we can change any of this to look the way that Savon is describing here in chat. You subscribe to a channel where we write code from scratch. We don't use any AI code generators or code helpers like Copilot, just all from hand, all code by hand. And we are writing AI. So we focus on AI, we focus on Python, and we might take Diverge and do a few other things. And we'll have different things, like we'll do algorithmic trading, we'll do more toy-based learning. We're walking through all of the Pytorch features and capabilities right now. We're getting very good at Pytorch. That's the goal. That is the absolute goal. Currently, the current goal is to get very good at Pytorch. We want to get I'm okay at AI by hand, custom coding it with the algorithms. I want to use the framework now. I want to use Pytorch, the framework. All right, so let's see here. Is there a way? So this isn't actually true alpha, which is very annoying. I want this right here to be true alpha. It is not. Okay. So 10, 10, that will be 100. That will be 200. See what that looks like. Here we go. So it looks good. It looks good. It's just not the kind of good that I want it to be. I need it to not override using the background color. All right, let's see if we can look that up. Let's see if we can find details here. All right, so ensure colors are in the valid range. Don't care about that. Draw full circle. Radius, position, color, surface. And our surface is where's our surface at? Where do we find it? Surface, screen, fill screen, yep, background, draw radial gradient. Okay, so that draws it there. Where is wait, hold on a second. Is this the right thing though? Hey, Steven, what country are you from? United States, in Seattle, Washington. We're over here in Seattle, Washington. Where's the thing at? Where's the thing that I was thinking of? I don't even see it here anymore. Where is it? Init, gradient, screen. Where is screen? are we looking at the right thing? Maybe we're not. Let's see here. No, get rid of these, get rid of those, get rid of that. Where did we get? Okay, so we do have to get going. We have to get going here. I just want to see if we can make this one little bit. I'm not seeing. Hold on a second. Heat map. See this right here. Source alpha. Let's do this. Let's grab this really quick. Source alpha. A flag used when creating a surface to specify that the surface should include a per pixel alpha channel, which allows for transparency effects. So let us also add this into our main window. That might help it. So where is our other surface? Surface. Screen. Where's screen at? Display mode. Set mode. Can we do this? We can, but it didn't do anything. It didn't do anything. It looks great. It looks great. You can see it's just I want the alpha channel to be preserved. What are you trying to build here? I just started watching you. Nice, excellent, Abhishek. So we're doing a click tracker. The AI learned to predict the next click. As you can see, the AI is learning. It's just not learning in the way that I want it to. So what we're doing, Savan on here and others, we're saying, hey, we need to visualize how it's learning over time. And so that's what we did today. We added the heat map. However, we ran into a technical challenge where the heat map, we need to have an alpha transparency. And you can see that I added radial gradient rendering, which I just added. However, it's not preserving the transparency every time I overwrite the surface area. So we need to do something a little different, because every time another circle is drawn on top of the previous circle, it completely eliminates the previous rendering. And so I'm trying to figure out what's a good way to deal with that, which we might have to save until to Drawing Brothers. Hey, how's it going? Merry Christmas. All right. We are out of time. It was great. It's great to spend time with you guys. Let me see here. Merry Christmas. Yeah, Merry Christmas. I'm wondering if there's a way to draw this surface better. Surface, heat map, window blitz. Let's see if we can ask the AI for help. The transparency is not preserved for each circle. Is there overlaid on top? Let's see if there's a way to preserve the transparency. Draw circle, do not perform alpha blending. Yes, that's what we need. We need alpha blending. I didn't know that was a separate thing. Yep, art red, green, blue, alpha. You got it, Kyle. You got it. Red, green, blue, alpha. So we need to do blending. Draw blend circle. Target surface, color, center, radius. All right. Center, radius, center. Okay. So there's a separate blitz the temp surface onto your main surface. Draw the circle to the temp surface, which is what we did. Wait, no. Okay, good. Okay, where is draw blended circle? Create the temp surface just for the circle. All right, so we got one temp surface. Okay, then we draw the circle under the temp surface, and then we blit that onto. Okay, so we need to create a temporary surface using the special blit flags. Blend. Okay. I would rather use this. How do we do that? Mathematically blends the source pixels under the destination. Okay. Let's do this. Let's add this. The sad thing is, it's almost the end of the day. I know, isn't it? It's already the end of the day. All right, so let's see if we can do that. All right, so when we draw that, is that gonna work? I think that might work just fine. All we have to do is this. Let's see if that works. Wait 1 second. Or do we have to do that here? Right, when we draw circle? If you want to modify how colors combine when overlapping, yep, that's it. You need to blit with special blend, add, or multiply. So I'll do multiply. I'll do multiply for lighting and shadow effects. Excellent. Pillow library? Wait, I mean, we could. That would also work by default. The pillow library would absolutely work by default. We're using Pygame. Let's see. All right, so let's try this. If that can even do anything. It doesn't like that. Invalid rect style argument. Okay. So, all right, let's ask how to use. All right. We could also just don't care about that. Let's see, color, yep, surface. We didn't make a temp surface, so I don't know if we need to or not. Blit, special flags. There's a special parameter. Okay. There we go. Special flags. We gotta use special flags. All right, now maybe we're good. Let's see if we're good now. Hey, all right. Well, it made it different. It didn't quite do what I wanted. It did make it different though. So if that's doing that, then one moment I need to also, let's see here, fill. Where's our fill at? So this needs to be 255. Okay. Still not. Okay. Are you using a user click prediction project? Yep, that's it. That's exactly what we're doing, using user click prediction project to do this. Let's see here. Surface. Looks good. Where do we want to, let's see here. Set mode blitz. All right, so maybe we need to do this for everything. Maybe, or let's do add. Let's try add instead. See if that makes it different. Yeah, it does. Okay. All right. Let me see here. Did we? So let's do. Theo is Light. Thank you for your subscription. Thank you, Theo is Light. Good to have you here. We're focusing on, of course, AI, Python. Those are the things. That's the channel that you subscribed to just now. We'll be doing coding all by hand. We are going to use, the Google search and whatever results come up with that to help us out on our journey to figure things out. We will be typing everything by hand. We won't use a code generator, and we won't use a coding autocomplete like Copilot. So that's our plan. So let's see here. Is that going to be a different color, or is it? So all of our alpha is gone now, which is weird. Let's see here. Special flags. So we only have one special flags. Let's add the special flags everywhere. Let's do blit. Oh, we only do one blit. Interesting. Do we want? Can we do that here? Maybe. Let's look here. It only on the blit. Multiply onto the mask. Transparent areas in the mask alpha will become transparent. Here we go. Add channels that result as brighter masking, fading, and tinting. Okay. All right. Well. So the thing is, this does not do what I want here. No, because it's still not what I want. Let's get rid of the special flags really quick. Special flag. Also, maybe instead of that, we could, where's the surface at? Where's the heat map at? Where's this defined heat map? What if we got rid of this? Does that make it different? Didn't do anything. Okay. Leave it there. I still don't get it. What is the goal? Oh, Drawing Brothers. So the goal is I want to make a heat map and I want to make it pretty. Right now, you're seeing all the previous coordinates being rendered onto the screen where the AI is predicting its output to be. Essentially, this golden circle on the screen is where the AI is predicting the next click. I want to track all of its predictions over time as it's training and seeing all the clicks, which is going to help us optimize our model for the best possible AI to click predict. That's what we want to do. We want it to predict all of our clicks. It would be easier with an image probably. It would be, yeah. So we would just do our own image and we would blit the full image. And it would include alpha channels. We absolutely could. Though for some reason, so we're only blitting once here? That can't be right. That can't be right, is it? So if we add, let's see here. Let's actually, here's what we do. Let's just remove this for a second. Go back. Okay. So we did run out of time. So here's what it looks like. It looks pretty good. It's kind of hard to see. I'll brighten that really quick. I'll brighten that. So let's bring this up to 25. So it'll be very bright. There we go. Here we go. So there, now you can see the only thing that's not happening is not preserving the transparency for every single circle that's rendered. As you can see, you see this trail here, sort of like a trail that's happening. And I want it to look more like a heat map. Theo is Light, thank you for your subscription. I think I can actually capture your screen or your current mouse position, and then eventually you could even have it monitor your daily clicking activity and possibly predict what you do next. If it had enough data, you're absolutely right. It would be able to click all that, because I repeat a lot of stuff throughout the day. If it captured the screen, it would know where to click. Essentially, you'd be training an AI to do that. That's a really good idea. Theo is Light, and you could actually have it do tasks like you would. Yeah, you could. You're absolutely right. Oh, I get it. We can use that model to click where the user would click. Yes, exactly. Add a cart to button, click the search box, productivity AI tool. You got it. We can do a lot of things. I want to take this into the Chrome extension. You absolutely could. You could make this a Chrome extension. It is a very lightweight AI machine learning model. It does not take a lot of compute. This could work very well as a Chrome extension. Thank you, you guys. Thank you for the likes. So we had a lot of fun. We had a lot of fun doing this today. We'll be back tomorrow. Tomorrow. Yeah, we'll be back tomorrow, and we will continue this. We'll continue to make this look good. So we'll make the AI, the heat map better. We'll make it look better, right? So we are getting a radial gradient, which we had to code by hand, which wasn't hard. It turns out it's not a hard task to do a radial gradient. But yeah, see, this is what I'm looking for. I want this sort of pattern. Right now, it looks like a lot of chaos on the screen because the alpha is not being preserved every single screen blit. So we need to add a multiplication on multiple layers. And right now we're not doing it right. What time is it? It is 10:20 and I'm over by 20 minutes. I do got to get going. I want to take these live streams become addictive. It's a lot of fun because we're learning together. We're working together. We're figuring things out. Have a good stay, Stephen, and everyone else. Yeah, thank you, you guys. It was great to have you all here. We'll be back. We'll be back tomorrow, and we'll continue this. We'll make it better. We'll make it better tomorrow, and we will learn more. We'll learn more together. All right, everyone. Have a good day. See you guys tomorrow. See you guys. See ya. Thank you for joining.